Okay, let's try to bring like all of these ideas that we've learned so far, bring them all together under the roof of one example. So suppose scores on exams in statistics are normally distributed with an unknown population mean and a population standard deviation of 3 points. A random sample of 36 scores is taken and gives a sample mean of 68. Find a 90% confidence interval for the true population mean of statistics exam scores. Write an interpretation. Okay, so what we're trying to do is based off of 36 student exam scores. We're going to try and create an interval or a range of numbers that has a 90% chance of actually capturing what the population mean is, or what the average score for all students, statistics students would be. All right, so let's look first at the information that we were given. We're told that exam scores are normally distributed. So I think our random variable is composed of exam scores, and that this is normally distributed. The population mean is unknown, and the population standard deviation is 3 points. So we know that the population standard deviation is 3. A random sample of 36 scores, sample size of 36, is taken and gives a sample mean of 68. So a sample mean of 68. So find a 90% confidence interval for the true population mean of statistics exam scores. All right. So because we are looking for a 90% confidence interval, that means the confidence level is going to be 0.9 or 90%. And what we need is we need to construct this confidence interval. All right. Let me put at a 90% confidence level. Now, with what we're trying to create here, we need the sample mean, which we already have. So what's left for us to figure out then is we have to calculate the error. All right, so let's maybe try and trace this as a series of steps. So we're trying to calculate the error bound for the mean, and we have an equation for that. So that is z alpha 2 times sigma over the square root of n. All right, so in order to calculate the error that we need here, well, we need the right-hand side of this equation. Sigma is already given. N is already given. So what we need is we need to calculate this Z alpha 2 score. So how do we get that? Well, this Z alpha 2 score, this relates to a normal distribution. So let's draw a normal distribution. And let's see if we can't identify where that Z alpha 2 score is on this picture. All right. So we have our normal distribution here. The center of this is going to be, we'll just put our sample mean as our point estimate. And we have a 90% confidence level. Now, when constructing confidence intervals, we're going to have two boundaries. We're going to have a two-tailed distribution. And this critical value is going to be our positive Z alpha 2 score. And the critical value down here is our negative Z alpha 2 score. Now, where's the confidence level in this picture? Confidence level is the larger area between the two boundaries. So the 90% confidence level is this area here in the middle. So if that's the confidence level, then the area in the tails is our significance level. And it's going to be the significance level divided by 2, because half of the significance level is here and half of the significance level is there. Well, if the area here in the middle, the confidence level area, is 0.9, how much is left in the tails? Well, the confidence level plus the significance level is equal to 1. And if the confidence level is 0.9, then we can subtract 0.9 from both sides. And the significance level is equal to 0.10. And if we divide that in half, then we've got 0.05. So the significance level divided by 2 is equal to 0.05. So we have an area of 0.05 on this side and an area of 0.05 on that side. And notice if we add 0.05 plus 0.90, that gives us 0.95. And 0.95 plus 0.05 will give us 1. So all of these areas added together add up to 1. Okay. So now that we got this picture drawn in, how can we calculate this Z alpha 2 score? We need an inverse distribution function for that. And that's why I've put these calculator functions up here. Because an inverse distribution function will let us take an area and convert the area into a value on the number line. And there's a lot of different options we can go with. We could use this area to calculate that Z-score. We could use the confidence level here in the middle to calculate this Z alpha 2 score. I'm going to use this area in the tail in order to calculate this Z alpha 2 score here. So if we're using the Texas Instruments calculator, we're going to use inverse norm. I'm going to put an area of 0.05. Now, because we're dealing with Z-scores, the center or the mean is 0 and the standard deviation is 1. And I'm going to put in an area of 0.05 and we're going to calculate it from the left. If we're using the NumWorks calculator, we'll have a mean of 0, standard deviation of 1, with an area of 0.05, and we want the area on the left. All right, so let's go ahead and do that, and let's see what Z alpha 2 score we get, because once we get it, we're going to be able to plug it in right here, and then we'll be able to get our error. So let's see what we get. Let's go to this guy. All right, let me clear that. S2. Okay, so we want to go to the distribution functions, go to inverse norm, an area of 0.05 with a mean of 0, standard deviation of 1, left tail. And I'll hit paste there in a minute, but I wanted to do this on the NumWorks calculator. So I want to go down to the distributions app, go down to normal. Okay, mean of 0, standard deviation of 1. And I want the area to the left, and I want 0.05, or an area of 5% probability. So that gives me, now it's giving me a negative 1.645. We want the positive version of this because error is going to be positive anyway. And if we come over here to Texas Instruments, hit enter again, and you can see it gives us the same value, 1.645. So come back. So the z-score that we're calculating, the Z alpha 2 score, is 1.645. Now, if we wanted to be ultra accurate here, let's take on the Texas Instruments, let's store this value. I'm going to multiply this by -1 to make it positive. Let's store this value in the variable z for z-score. So I'm going to hit store and then alpha 2, enter. Okay, so it put that in variable z. And I think I can select this number and let's just hit store. Yeah, so I selected it and I hit Shift X to the Y. So I'm going to store this in variable Z. So I'm going to hit Shift Alpha plus, and that'll give me a capital Z, and hit execute. All right, cool. On the NumWorks, let me click on Home so that I can get back to the calculation app. Okay. So as a filler here, I'm going to put 1.645 that we just calculated. Standard deviation is 3 all over the square root of 36. And I think I can kind of simplify this a little bit myself. The square root of 36 is just 6, and 3 divided by 6 is 1/2. Or 0.5. So I'm going to take that variable z and I'm going to multiply it by 0.5, by 1/2. And that should give me my error bound for the mean. Come back over here. And, on this one, I could just put divide by, or not divide by. I could put times 0.5. That's going to do the same thing, 0.8224. If I wanted to use that variable z, I could put z times 0.5. It's going to give me the same answer. Let me come back here to the NumWorks calculator. Um, and so I could do Shift Alpha Z and then put times 0.5. And you can see I get the same answer. It's negative, but I'll just put the positive of that because error is always positive. Another cool thing about the NumWorks calculator, if I go back to that distributions app, here, what's neat is that this has a copy paste function. So you'll notice it's got the word copy here in orange. So I think I can hit Shift copy. Okay, and it copies that number. I can go home, go to calculation, click OK. And now I can hit Shift and paste. And then I can put times 0.5. And it gives me the same answer. All right. So let's come back. So the error, I'm just going to put at 0.822. Okay. So the reason why we were calculating error was so that we can use it in conjunction with our sample mean as a point estimate for the population mean and put plus and minus error. So let's see here, X bar, we want to put this as X bar plus and minus error. And X bar is 68 plus and minus 0.822. So this is our confidence interval for the student scores. Okay. So, this problem, is significantly more intricate, as far as all the different parts that we have to put together in order to solve it. And it's really hard to kind of formulate this part in your mind, especially when you're first starting out in statistics. Okay. Which is why in the past few chapters, I've been repeatedly drawing this out, actually drawing this distribution and marking the different areas in it for this particular reason. It's to help you visualize the different parts that you're calculating and the relationships that they have with each other. You want to be able to help your brain by using your eyes to see those relationships. And make sure that you write everything down on the page. And, you work everything out one step at a time, changing only one thing at a time. Because having written it down this way, you'll also be teaching yourself how to do this again later when you have to prepare for the exam. All right, so that completes this example. Let me know if you have any questions.